Hello everyone and welcome back. So this time we're actually going through power examples. This first one's a pretty easy example, but let's figure it out. So a small nuclear reactor with an electric output of power of 5 megawatts is to be designed to power an initial settlement on Mars. Express this power in joules per Earth day. Okay, joules per day. And it wants us to give it in nice prefixes. We'll get there. So first off, 5 megawatts. Now what is a watt? Well, 1 watt is equal to 1 joule per second. That is supposed to be a capital J, but your professor's handwriting is absolutely horrible. There you go. Okay, so 1 joule per second. We have 5 megawatts, so that would be 5 million joules per second. And it's saying how many joules will we have per Earth day. So we need to change this from 5 million joules per second to something joules per day. Okay, so quite a few conversions going on here. I want to take a couple of shortcuts. Remember, there's 3,600 seconds in an hour. We'll use that to help us out. So 5 million, 1, 2, 3, 4, 5, 6 zeros, joules over seconds. First conversion is going to be from seconds to hours, so 3,600 seconds and 1 hour. And the second conversion is going to be from hours to days. And there are 24 hours in 1 Earth day. Okay. Now if I plug all this in, you know what? Let's do it. Let's do it. So 5, 2, 3, 4, 5, 6 times 3,600. Good so far. Times 24. 4. So 432 billion. What we can remember is that if we're doing with the prefixes, billion is giga. Think about a gigabyte. It's a billion bytes. Okay, so 432 back in here. Gigajoules per day. And if I hit the next, I'm right. Woo! Okay, so we did it. Worked out pretty well. And now let's go ahead on to one more example. So assume we have a motor that's rated for the power of 80 watts, but experiences 20 watts of heat loss during operation. Suppose the motor is surrounded by 0.75 cubic meters of air, at specific gravity right here. It runs on an intermittent cycle for 2 minutes before fan turns on. How much thermal energy in units of joules was released to the space surrounding the motor in those 2 minutes? Before we go anywhere, let's look at our equation. So our power equation is P is equal to E over T. This is not pressure, that is power. Carefully, don't get those P's confused. Okay, E over T. We want to solve for E, that's what we're looking for. We have a time, that's going to be 2 minutes. I'm going to go ahead and convert that to 120 seconds. So P is equal to E over 120 seconds. So all I need to know now is the power. What power was going to the air in its form of heat? Well, this right here. That's it. So the answer would be the energy in joules is going to be equal to 20 times 120. It's going to be equal to 2,400 joules. And you're done. That wasn't necessary. This wasn't necessary. Even that wasn't necessary in the end. So problems will sometimes give you a whole lot of extra information that you don't need. Remember that. Okay, remember that you don't need everything that's given to you. Not always. Or sometimes you'll be given enough information to go several different pathways, but there's going to be one that's fastest. Either way, make sure that you're prepared for that. Because in real life, that's what's going to happen. People are going to give you way too much info. Like, you don't need to know everything, but they're going to try to tell you everything. And so you got to be able to figure out how to take the good and the bad and toss some of it out. Okay? Well, I hope this helped you. And I'll see all of you next time. Bye-bye.